Okay, ready to go. Hello, everybody. Good morning, good afternoon, good evening, depending where you are. So today, my focus will be on the MS plugin and really focus on what I call open access LCMS data. And what I mean by that is the focus here will be more on the UV section because reaction monitoring, purity of products that are made, the focus is UV, with secondarily looking at the mass spec. So that's the reason for the title. Some of you may be running a water system using OpenLink software or using Diversity Browser on your desktops to look at the data afterwards, or you might be using Agilent and OpenLab, whatever software you're using. The Mnova plugin is a very general software that can integrate any kind of data types. So I'm going to present maybe 5 slides, just an overview, an introduction, because my main focus is the workshop and going through the demo and answering questions at the end. The workshop will be around 45 minutes or so with the presentation, demo, and questions at the end. It can go longer if I want to answer more questions. So let me get started. Okay. So we've offered now about 12 of these training sessions. This is the last one today. We've offered them in the areas of QNMR, our MBook and MBook ELN, various other areas. There's a link there for past presentations. So let me go on from that. Just give you an idea of the product range, and this may be redundant, but just want to highlight it. Today we're focused on the sort of 3 basic plugins, or 3 basic items that we have: NMR, mass spec, Elvis. The NMR obviously looks at the NMR spectra. The focus today will be on the MS plugin. Elvis can look at UV data, Raman data, FTIR. That's another plugin. And then we have various advanced and specialist tools for screening, for structural elucidation, QNMR, etc. Databasing, IUPAC binding. And we also have, down at the bottom here, MBook, which is an ELN tool for chemists to document reactions and products made, which can also be used in a tablet form or on the PC. And sort of the newest product that we've had and a drive within Mestrolab is what we call MGears, and that's our sort of automation engine. I'll mention that in a couple of slides. The main philosophy of Mnova, and the thing that really attracted me to Mestrolab is the fact that we listen to our customers. We build tools that the customers want to advance their science. We take that feedback. We build the tools. We tailor them to the needs of the customers. That's the big, I would say, overall philosophy within Mestrolab. So why Mnova? What's special about Mnova? Well, again, it's a single software that can look at various amounts of data and all types of data, from NMR, LCMS, GCMS, Raman, etc. It can look at different data types. It doesn't matter what the vendor is, so it's agnostic of the vendor. You can look at it from any computer. You can network. It can be a local computer, a workstation computer. It could be a tablet. And it currently works with three types of OS: Windows, Mac, Linux. And I would say it looks very simple from when you first look at it, but it's very powerful. Has a lot of advanced and powerful tools built in that you just need to unlock as you get more comfortable. And like I said from before, the MGears automation, that's where we're driving a lot of our efforts in the last year or so. And I just want to give you one example of that before I go on. So we have a couple of pharmaceuticals that have mass specs and NMRs at different sites, say site 1, site 2, and they want that data to be centralized in a database and an ELN, but they don't want to have to do it manually. So MGears is a tool that can do that. It can pull data from the NMR and mass spec folders. It can do it unattended in real time, what we call it listens to folders. It can pick up those files, can put them in an Mnova, sort of is the, I guess the fork in between the database. It can then store it in a database, can put it in a PDF repository or even an ELN. Then once you have it in a database, the experimenters at the bottom can review, reprocess, search, all they want. So that's the one thing sort of that we're driving. The next slide is really focused on the MS plugin. I just have one slide for this. Like you see on the left, we can look at Agilent data, thermo, waters, etc. It's one GUI that can look at multiple data sets. And let's go to the demo. Okay. So what I'm going to do here is, so this is Mnova. I've opened it up. Blank. There's nothing there. All you see is a column that says pages, and that'll have a list of all the pages you're currently working on. This is sort of the desktop. And the first thing I'm going to do is turn on the data browser. If I just click here, I know you're following along, so I'll try to go slow. This is the new modern ribbon that we have up top. We've used the classic view in the past. This is sort of the modern view. You can access the modern view up here in the preferences. Let me just show you really quickly. If you click on that, over here in the theme, I've chosen the modern, but you can also go back to the classic. So first thing I'm gonna do is I'm gonna turn on the data browser. Let me walk you through, for those of you that haven't used Mnova before. The data browser is a place where you can have all your folders visible without having to go back to your Windows folders or your network folders and so forth. And so what you could do here is if you click on the plus, you can add a location. That could be any location you want. It could be on a network, it could be on own cloud, it could be on your local PC. You can just pick whatever folder. Once you've selected the folder, which I have here, and you can just go down the tree and pick the data that you want to look at. So I have demo data here, and I'm going to use the MS demo data that you should have with you. It's the reference mix raw data here. And all I need to do is just drag it. Yep, so I just drag it. Let me make this a little bigger. So that's the raw data. And what I'm going to do now is I just want to go through all of the options and how to manipulate spectrum, how to integrate, how to look at the mass spec, how to align the UV in the mass spec, just give you an overall view of what I'm going to do. And then what does the output look like? How do I manipulate the output to make it look the way I want? So the first data set, like I said, is this reference mix. It has about 6 or 7 compounds in it. I'm not going to focus on a lot of them. I'll just pick 2 peaks out of there. The first thing I typically do when I'm looking at a mass spec is, from an open access perspective, is I need to make sure that the UV and the mass spec is aligned, because in a lot of systems, in every system, like the flow goes through the diode array first, goes to the mass spec second, and that tubing delay between the UV and the mass spec offsets the mass chromatogram from the UV chromatogram. So I can see up top here that I have the PDA and I have the TIC positive without focusing on anything else except just aligning traces. A few commands that I use from the keyboard I'll talk about, or let me go through those in a minute, or you can use these commands here with expand, zoom in, and so forth. But what I'll do is, if you hit Z on your keyboard, that gives you this plus cursor, and that's the expand cursor. So I'm going to expand these 3 first peaks here. And then if I hit escape again, puts me into the pointer mode. Of course, if I hit Z again, I could expand again. I'm going to go escape, but I want the full spectrum back. How do I get that? Well, if I'm in the pointer mode, I just click the F key. That gets me back to what I call full. So I like to use those three keys rather than dragging my mouse over here, but you can feel free to, you could do the same thing here. If you hit escape, you get out of it. So, okay. So for me, I just love to use the the keys on the keyboard. Okay. So let's align the spectrum. If I look at the TIC here and the UV, I can see that they're off, but the peak matches make sense because that probably belongs to that one. This belongs here and so forth. See the correspondence. So I know that that UV peak is actually this mass spec peak. So I'm going to go up here under Align Traces. And then you can see this little time icon that comes up. And I'm just going to click on the UV, and then I get this little window. So that's the retention time here. And then in here, I can just type in a new retention time, and I want it to match the positive TIC, right? So I'm just going to type that in, 8.155. I'm going to select the row, and I'm going to say OK. And I'm going to go back to full. I'm going to go expand again. And now you could see that the UV is now aligned with this peak and so forth. So that's the first thing I typically do. Just give you a minute to organize yourself. The other thing I want to talk about before I get into integration, well, let me do that first. I'll do integration. So if I right-click on any of these traces, I get a bunch of options. Down here around peaks, I can clear all the peaks if I want, so it gets rid of all integration. You know, I could do it on the TIC, so I can remove all integration. I could set a threshold for integration, so instead of clearing, I click on options. And you can see here is a minimized threshold. So, you know, I could set that, say, if I set that to 2%, it'll integrate anything at 2% or above, even this little peak, which is 2.02. And then I'm going to expand just so we can take a look a little closer. You can see it's integrated all those peaks. If I go back to options, let's say let's set it even higher. I don't know, 10%. Got rid of that one because these are above. One more time, let's try it one more time just so we can get practice. Let's try 15%. I got rid of all those. These are above. Okay. So I'm going to clear all the peaks. So that's a way that you can do an automated integration. Sorry, I keep zooming in and out because I just want to see what it looks like overall. So I'm going to zoom back in. And let's say I want to do a manual integration this time. So the ribbon here, I'll go through a couple of the items, but right now let's focus on detecting peaks. If you click on this add peak symbol, right, and you get this sort of command, now I could just pick and drag peaks like that for integration. Let me just finish a couple of these. So if I could do that, I could also do it on a TIC if I want. Pretty easily. If I want to get rid of an integration, I could just go to the this icon, which is delete peak, and if I just drag, you know, I can get rid of those. I can get rid of all of them. So these set of icons help you integrate, remove peaks, and so forth. I'll just give you a minute here. The other thing you can do is, let's say I'll go back to just automated integration. Let's just back to 2%. If I wanted to, I'm going to expand this region. If I wanted to change the width of the integration manually, I could do that by just dragging. If I just hold the wedge, I could drag it this way, drag it that way. Obviously, that's not a good way to integrate. So I can go back if I want. If I want the integral to split like a perpendicular, if I just hold the shift key, and it'll do that rather than drag it across the peak. Or I can go back to that. I want to widen it a little bit. So you can manipulate it and tweak it if you want here and there. Okay, so I'm going to go back to full and just expand the, I'm going to hit Z again and just expand the UV there. Okay, so now I want to spend some time a little bit on this MS browser window. You can see once we dragged in the mass spec, this ribbon came up, and also you can see the the data browser is still there. It's just in the background, and now you get sort of an MS browser. And what is that? That really lists all the traces that were acquired during the experiment. So I can click. So for example, there's a TIC positive here. They've also collected a TIC negative. If I want to add that to the window, I can just double click on it, and then it asks me if I want a base peak, a mass peak. I'll just do total ion current. So it adds it to the bottom here. You can see here, this is the negative. Yep. If I wanted to move that spectra up and down, or put it in the middle, put it on top, I can do that by right-clicking. And then in the middle here, you can move it to the top if you like that. Or you can move it down one, or move it down one again. So you can manipulate where you want things to show up. You could delete this if you do a delete plot. Now it's deleted from your visual, but it's still here. I can still bring it back. It doesn't go anywhere, and it's at the bottom again by default. So let me delete that. If I wanted the UV, so the UV right now is just a wide range wavelength UV. If I wanted, say, if I double click on the diode array here and I wanted, say, 254, I can just type in 254. Again, it's going to put it on the bottom. If I want it on top, right click, moves to the top. Okay, so that's a way to bring in TICs. It's a way to reorganize the order of spectra or chromatograms. It's a way of just bringing in and out whatever functions or traces you want to look at. The other thing I want to show you is if you go under the View menu, in the middle here, there are different ways to visualize what you're seeing in terms of the size of the picture. So right now, you're seeing the whole page in view, but if you want to see it more close up, and just click on, sorry, not page width, entire window, just makes it a little bigger so you can see it. Just zooms in, but if you want to go back, you can go back to that if you want. That depends on what you want to see. So that's a way to manipulate that. Okay. So let's arrange this in a manner that we'd like to see it if I'm looking at a reaction monitoring. Let's say I've just ran a reaction, injected the sample in the mass spec, and I want it organized in a certain way. Typically, what I've done in the past when I worked in pharma is I had the UV spectrum at the top, and then I've extracted the spectra for multiple peaks on the bottom on one page with a positive, and then I've had another page where I had the negative spectra. So let's try to do that manually. So let's get rid of the wide range UV here. Let's get rid of that one because all I want is this one. And I don't need the TIC anymore since I've aligned the peaks, and I'll show you why. And I'm going to get rid of this mass spectrum. Okay, so all I have now is the UV. Okay, and now what I'm going to do is I'm going to clear all the integrations. If I right click, clear peaks, and I'm going to focus on 2 peaks. I'm going to go back to the mass ribbon. Remember, I was in view to change the view. If I click on the mass ribbon, I'm going to go back to the integration, add peak. I'm going to pick this peak at almost 9 minutes. That one. And I'm going to pick the peak at about 12.1. I'm going to assume, pretend like I've run a reaction. This is my target API, and there's some side product, let's say. And I'm going to ignore the other peaks. So I'm in this mode. If I hit the escape button, it removes that add peak. So here I am, just look at the UV. So those are the peaks I want to integrate, great. But now I want to see what the mass spec looks like underneath. So now if I go to the crosshair tool up here, just give you a minute to do that. And if I just drag my crosshair across the peak, it's going to display the mass spectrum, positive mass spectrum for that peak at the bottom, right? And if I want to scan the chromatogram to see what other masses are there, if I just move my crosshair across the UV, I can scan it. So I can scan what's under that one, and so forth. So you can evaluate what the other peaks are just to get a qualitative view of what other masses are there. And this would be my sort of pseudo side product. Okay, but so if I remove the crosshair from view, and let me just I'll hit escape. What happens is it just goes back to what I selected initially. So that's the mass range that I selected underneath that UV. Okay, now I want to add this one on the bottom. So if you click on this button, which is the append, so now when I choose a second peak, it won't overwrite this one, it'll append it. So if I scan that peak, let me hit yep, and let me hit escape, yep. So what I've done now is I've added the mass spectrum for that one here, and I've added the mass spectrum for that peak here. Okay, so now I have a UV spectrum on top, which is what I typically like to see, and I have the mass spectrum on the bottom. Okay. Another thing I can do is, what if I wanted to look at the extracted ion of, say, the 438 peak? Sometimes we like to look at that. Sometimes the TIC is so general. So I'll go back and bring back the TIC. So I want the positive TIC, which is here. Total ion current, just by double clicking, it's on the bottom. I'm gonna bring it up a little ways. Just 2 steps up, bring it here. And I'm going to clear, if I right click, I'm going to clear all the integration. I don't need to see that right now. And I'm going to ask the question, let me, it's offline right now because I just brought it in. So if I just hit full, it aligns it back up. Okay. So I want to look at the extracted ion of 438. Where does it reside in here? So if I go up to the ribbon and I go to the new chromatogram, so that's the extracted ion chromatogram, and I click on manual, gives me a little window, and now I can put in here the mass of that target there. So I'll give you some time to do that. Let me do that again. So if I click on the TIC, I'll bring it back in again. Let me just do that. I'll just go back one step, make sure I'm going slow enough. So I'm bringing the TIC again, double click, total TIC, and I'll bring it up a couple of steps. Actually, I can move it to the top and move it down one. Or that's another way to do it. I'll keep the integration. So I'm going to come up here. So this is selected. I'm going to come up here to the new chromatogram, manual. Okay. And again, I'm going to just type in that number there. 438.20. Tolerance at 0.25 Dalton, that's fine. You can make that wider if you like. And see what you see down here is now the extracted ion of 438.2 from the TIC. Let me move it up to the top. If I right click, and you can see here, and I'm going to, so I have it here. That's the UV, that's the TIC. I'm going to expand this peak so I can just take a closer look. I'm going to hit Z on my keyboard. And I'm going to hit escape. And you can see it lines up with the UV and the extracted total TIC. So you can do that for whatever. If you're searching for a mass, let's say you know there's some side product that you know about and you don't see it in the TIC, I'm going to hit full. Because the TIC is usually very broad and very general. This one we're lucky has a lot of features, but typically it doesn't because of solvent background or disionization, matrix ionization issues. Yeah, so you can search for masses in the negative and the positive. So that's demonstrating the peak period, the extracted ion. So I'm going to delete this now. And I'm going to delete that also, the TIC. So I'm going to right click, delete. So I'm back to my UV up top, my 2 mass spectra at the bottom, right? And let me just take a look. Now what I want to do is I want to display on another page the same UV spectrum. And instead of looking at the positive ions, I want to now look at my negative spectrum, because you know as well as I do, when you're doing a reaction and you get a product, typically all methods scan between positive and negative because you never know which one's going to be stronger, which depends on matrix effects or the functionality, the groups in the molecule, like a carboxylic acid, show up better in the negative. Pyridines, amines will show up in the positive, therefore things like that. So without making any assumptions, typically mass spec instruments the methods will scan both. So what I'm going to do is I'm going to right click on the UV. I'm going to go down to extract plot. And what that's going to do is it's going to take that UV spectrum and put it on a different page. Like that. Okay. I've already integrated it. Just makes a copy of it. Okay. So I already have this page. I'm happy with this. This is what I want to print. But now I want to look at the negative. So if I go over to the mass browser, you notice here that there's a star by the positive TIC, right? That's because the star indicates that when I scan the UV peak with that crosshair tool, let me go back up here, it's only going to result in the display of the positive spectrum. Okay, let me go back to this. So now I want the negative. So I'm going to click on the negative TIC, and I'm going to change where the star is, where the star is highlighted. So now it's highlighted on the negative trace. So now if I go back to the ribbon and go to the crosshair, I'm going to scan the same peak, same exact peak. So I'm going to scan that one. That gives me the negative ion for that one. And again, I've already had this append button click, so I don't have to click it again. So that when I scan the second one, I'm getting the negative of that one. I'm going to escape again so I can get out of that mode. So now I have 2 pages. I have this one, which has the integrated peaks I want, positive spectrum, and I have these two pages with the negative spectrum that I want. Obviously, these ionize much better, and the positive much cleaner, much stronger peaks. So let me stop here, let you catch up. And now I'm going to go over a few highlight features. If I go down here, I know that the M plus H for this, although it's not very clean, for this molecule is 361.09. But sometimes when I'm looking at the fragments, say like 233 and these upper fragment adducts, I'm usually on a calculator trying to calculate them, or on a ChemDraw trying to draw structure. So you don't have to do that here. There's a neat little tool called relative mass display. And then you get this window. So up here at the relative mass display, if it's already chosen the 361, which is great. So if but I could choose any mass I want. I could choose this one or that one, but I'll choose the M plus H. So what happens is now it puts everything relative to the base peak. So now I could expand here and just take a look. 361 is a loss of 128. Wonder what that is. A loss of 49. And these are just higher adducts or maybe impurities. So that's a nice, useful feature. I'm going to click the F just to go back to full. That's a nice, useful feature just so that you can look at the mass spectrum and try to figure out what the losses are without having to do some subtractions. Okay. Okay, so we did that. Let me just make sure I'm covering. Okay. So we have our two pages that we like to see. If I had an ELSD trace here, I can include it. I don't have one here. So now I'm going to focus on what else do I want to display on these pages. Well, I'd like to see the peak integration for these two and these percentage in the table. That's sometimes useful. And if I go up, so now I'm in the ribbon. This is the area where we did all the integration. If you click on that table, that's the peak table. And for me, it shows up on the right, but I can detach it. You can put it whatever you want. You can put it here. As soon as the window highlights, you can move it around. I can pick it up again. I usually like to have it here. So let me wait for you to do that. So again, it's this show peaks table up here. Okay. If I click on the UV spectrum, what will be displayed over here is what I've integrated, right? I've particularly picked these two peaks, right? And it has a total area, the retention time. If I want to change that, let me widen this a little bit. There's a setup option here. And you can include a lot more information than I have. You know, scan type, height, area, if you want to see that. Start time, end time, you know, label. You could do a bunch of different things. You could change the borders. Let me show you that in a minute. So I've chosen just to be very simple, just to have the retention time total area. That's usually what I'm interested in. But let's say I want to label this peak with that mass. So what I could do is I can choose that line. So I'm going to pick this label. I'm going to set a peak label. And I'm going to write in 438 M plus H. I'm going to click OK. So now that label is added to the peak there. See it there? That's always nice to see. Usually in an open links report or something, you'd see something like that. And then for the other one, I could do the same thing. And I'm going to put the 361. Point, I'll just call it 10. You can see it's added to the top there, right? So you can You can add whatever labels you want to this. And I could do the same with these, and I could do the M-H if I think they're prominent enough, or I can label A, B, whatever. So at this point, I'm pretty happy with this. All I'd have to do is to file, export PDF, save it somewhere, and you'd have that PDF. One way to export it. Okay. Okay, let me check to see. Okay, at this point, what I'd like to do is to switch to the other data set that I forwarded to you guys. So what I'm going to do is I'm going to keep this data set here. We're at about 35, 40 minutes. So I want to go to the different data set and just show you some other options. So on mine, I have the new page. I can add it here, or you can go File, New, either way. I'm just going to click on New. I'll let you do that. Notice this goes blank because there's no data set yet. I'm going to close the Mass Peaks window, just exit there. We'll go back to my data browser. Now I'm going to pull in the ibuprofen data. I'm going to pull in the Waters Open Access LCMS. So that's the UV, TIC, and a spectra. And then I'm going to go back and I'm going to pull in the mole file, or you can paste your ChemDraw structure, or if you go up here under molecule, you could draw the structure right on the screen. Either way, there's 3 different ways you could do it. So I have ibuprofen. One thing I wanted to show is this molecule match feature. So if I click on molecule match, I have the structure and the UV and the mass spec. Mass spec. You get a new window up here on the right. Let me open that. And basically what that's done is taken the structure and the M over Z value and looked to see where it is in this chromatogram. Now the green check means it found it. The match score is it's almost 1. The retention time it's found at is 3.24, pretty close to 3.2. And then it also lists the predicted and match. Again, these windows can be optimized by just clicking Setup and manipulating what you want to see. I could also, let me make that a little smaller. I could also paste this window into the spectrum. So if I click on report, that molecular match, I can put it wherever in the spectrum. Let me make it a little wider. Oh, it's not doing so good there. I can adjust it, and notice that the borders here are double borders. That's everything. You can set all that up here, down here with the frame and so forth. So you can manipulate that. If I go back, so what I want to do is now switch back to the old data set back here. I'm on the UV here, trace. I'll just give you a minute. So I want to visualize my peak table again. I just go back to here, show peak table. And here it is. Let me close the molecular match. And let's say I want to display that. I would just report that also right there with the retention times. You could do it on your other page too. Okay, I'm almost done. I just want to do a couple of things. Automated output. I'm going to create a new page. And let me close this window. I'm going to bring in the ibuprofen again. So I'm going to bring in the open access waters. And notice how it goes back to the MS browser so you can manipulate the traces. But I'm going to go back to the data browser. I'm going to pull in the mol file. Now I'm going to use a script to generate a report that I like to see, that we've put together or developed. So if I go under, you don't have this script, sorry, I didn't send that, but I just want to demonstrate. I'm going to use a script called M2. And just give it a minute to reorganize this pages. I'm going to go back to view and go entire page. Okay, so what this script did is, and I can move things around even after if I want, like the structure. So this particular script that was written for a company, basically, actually, let me make it a bigger view so you can see. Let's put the picture of the molecule here. This is the LSD trace in this case. They like to see that first. This is the peak table for the LSD trace. And second thing they wanted was the diode array data, again with a peak table and the masses found. Positive TIC with a peak table also for the integrated peaks. And then on the second page, I wanted to see a blow up of the LSD trace, and you can obviously manipulate it up and down if you want. So that's one way to set up sort of a quick output. This is, you drag the data in, you can run a script, and you get sort of an output that you'd like to see. Then that can be written for people and customized. So let me show you one more. I'm going to create a new page. And again, you don't have the script, so don't worry about running. So I'm going to incorporate a proton spectrum. Let me go back to view. Yep. And then I'm going to bring in the structure. And again, the open access data. This script will take a little longer to run because now it's going to do a bunch of things, and I'll describe. I don't need that because it will generate that. So go back to tools, and I'm going to run the NMR MS script. And now what that's doing is this particular company wanted the NMRs and the mass specs on one page for each molecule. And it's going to manipulate the proton spectrum and split it into two, give you two insets, upfield and a downfield on the same page. It's also going to generate the peak tables that we saw previous for the mass specs. That's what it's doing now. And it's doing a molecular match. So let me go back. It's done. So it's basically did a multiple hit analysis on the proton. It's giving you the acquisition parameters here. It's giving you expansions for the upfield and downfield peaks. It's put the multiplets in J format here. And on the second page, it's put the minus and plus spectra and the UV on the bottom. And I've done a molecular match to say that it's found this and matched at 3.23 with obviously the areas of these. So that's a nice way to get a quick output for sort of the report that you'd want. I think I'll stop here. I mean, I could go on. I'll stop here and ask people if they have any questions and try to answer a few questions.